the 5 countries involved, so Australia, Canada, New Zealand, USA, also which form the 4 core countries of the quadrilateral countries, but we've also had involvement with UK, Ireland, Netherlands at various stages, and more recently Sweden, doing different parts of this project. But in the lead up to this particular paper that I'm presenting, we had all worked on a what we call the phase 1 foot and mouth disease vaccination study, where we were using, all of our models were parameterized to represent a UK situation. So using UK population data, UK parameters, but using all the different models that we each use. So that has been published. In that study, we looked at we varied a number of parameters. So early vaccination versus late vaccination, varying the size of the suppressive zones, looking at just vaccinating in certain risk areas, and so on. And there was a broad agreement between the different models, all representing the same kind of outbreak scenario, that early vaccination was better than late vaccination. If you're going to vaccinate, you need to make the decision early and get started earlier. So that was one of the findings. The previous talk just now said that vaccinating cattle was almost as good as vaccinating all species. So that was one of the things we wanted to look at. So we selected a small number of variables that we were going to vary, and so we then wanted to repeat the study in each of our own countries. So we'd all worked on the UK scenario. Now we wanted to repeat that study in our own country situations. Okay, so the study objectives were assess the robustness of particular vaccination strategies under different demographics. So using our own farm population data, our own country-specific resourcing, etc. We selected the variables that we wanted to vary. Was vaccination timing, so early versus late. So we agreed that the earliest that we could probably type the field strain that we have, get vaccine released from the vaccine banks, delivered to our own countries, etc., was about day 10. So we wanted to compare if we started vaccinating at day 10 versus, say, a week later, starting on day 17. We wanted to look at this question of what if we only vaccinate cattle farms versus farms of all types, of all species. What if we had limited vaccine resources, vaccine doses, I should say, what about if we just limit it to what we considered to be high-risk parts of our own country? So it could be based on farm density or risk of introduction. So each country was left to define what they meant by high-risk zones. And then also we looked at having limited vaccine resources, either personnel and or numbers of doses that we could deploy. So I should say that in each of our countries we still see stamping out as our primary method of eradication, but vaccination is obviously does seem to present merits as an adjunct, so adding vaccination on top of stamping out. So stamping out would still continue, but we would be using vaccination strategically to assist the eradication program. So I've already mentioned the 5 countries that were part of this particular study, 4 different software platforms. So at that stage Australia had an older model called Ospread. They now have a new one called Addis, which the previous talk mentioned, Exodus for the UK, Interspread Plus for New Zealand and Canada, and the National Animal Disease Spread Model for the USA. So we used, each country was left to parameterize the model using their own data, and then to sort of set up the scenario, we wanted to represent a reasonably large outbreak in each of our countries. So there was some baseline modelling done, some sort of pre-modelling, and out of that each country selected one particular scenario that represented either 90th or 95th percentile in terms of the size. we then used that, each country used that particular scenario to then test out the various options. Okay, so, all right, so just very quickly, stamping out was the baseline, and then we wanted to compare vaccine strategy 1, 2, 3, 4, 5. So we had 3 vaccines. VS1 was, we had 3 kilometre ring zone of suppressive vaccination starting on day 10, and some resource limits. So it could be either personnel or the number of doses of vaccine that we had available. VS2 was 3 kilometre suppressive ring vaccination starting on day 17. So identical to this one, except a delayed start to vaccination. VS3 was similar to this one, except we were only vaccinating farms that had cattle on them. So if it was a cattle farm which also had small ruminants, we would vaccinate the small ruminants as well. It's just some of our models are not able to only vaccinate some species within a farm. It was sort of a farm level vaccination program. But if there was no cattle on a farm at all, so totally pig farm or totally small ruminants, then we wouldn't vaccinate. VS4 was delayed start, day 17, but only certain parts of the country which were designated high risk. And then the final one was early start, 3 kilometres, but much higher resource levels. Okay, so in terms of the analysis, we wanted to compare descriptive, the outputs, numbers of IPs, that's in infected premises, and the duration, the area under control in each country, but for the basically stamping out versus these 5 vaccination strategies. Some payoff, 3D payoff graphs, which I won't spend too much time on, but I'll show you some examples of those which allow you to compare the trade-offs between numbers of infected premises, outbreak duration, and the numbers of doses used. We did some multi-regression sort of modelling to look at numbers of infected premises and outbreak duration. So I'm not going to present all the results, but just to give you an idea of the kinds of results that we were getting. So this is New Zealand outputs. So these are box plots looking at the numbers of IPs or infected premises by strategy. So stamping out, you can see a much larger range of outbreak sizes, and vaccination definitely made a huge difference to that. So we must have a sleep going on. So screens. So you can see that a massive reduction in the number of infected premises. This is duration. Similarly with duration, and then the number of doses. So these are the range of doses. We're talking about sort of 130,000 doses. Different ones had slightly different dose requirements. But starting early, used less than delayed start, so outbreaks tended to be larger. So starting early was definitely better, and you can see the benefits here that you start early is better than starting late. And then there's very little difference between cattle only or high-risk areas. There's marginal difference there. And then large amount of unlimited resources basically gives you a very good outcome as well. So just looking at the results for Canada. Now Canada, their resource limits were for VS1 through to 4. They only had 250,000 doses available. So you can see that's why these box plots are very concentrated around 250,000. In the final VS5, we removed the constraint on the number of vaccine doses available, and we got a massive jump in the number of doses actually used, all the way up to over 1.5 million doses in the largest sort of outbreaks. But you can see that even with a limit of 250,000 doses of vaccine, there was an improvement on stamping out only. Now, this was the high-risk area that was selected in Canada, was in the Alberta province. Very high density of beef production units and feedlots. Okay, I better whip through these. These are these 3D payoff graphs that we developed. So there's basically on the x-axis we've got the number of IPs used by each strategy. So these different symbols represent the different strategies, and this is the number of doses used, number of IPs, and duration. So depending on what your objective is, like to shorten duration, if we're an exporting country, which most of us are, certainly New Zealand is, and you're wanting to regain trade, the best strategy is to shorten duration by as much as possible. So, so if I can go backwards here. So you would choose a strategy that minimised duration. So where's New Zealand here? So VS, this red dose here, was early vaccination, and I think VS5, which was early vaccination, unlimited resources, were almost identical. They certainly reduced numbers of IPs the most and duration, but they used the most number of doses. Also, late vaccination had a very high dose requirement. So I won't dwell on these any more, but gives you an idea, a way of comparing the strategies. Okay, so basically, very quickly, these are the results of the multivariable regression analyses. So in terms of IPs, timing, if you delayed timing, you increased basically the number of IPs. Down here, high-risk areas were not protective. They actually caused larger outbreaks, and resources and duration. So this is the effect on duration being the outcome variable. So duration gets increased if you only do high-risk areas. Large amounts of resources are both protective. Okay, so I think it does show that there's value in vaccination as an adjunct to stamping out for severe outbreaks in our respective countries. Most of the models and the countries we did agree on basically the effectiveness of certain strategies, and so these findings give us confidence in coming up with policy recommendations to our respective governments as to how to respond to FMD outbreaks. Okay, so they supported the previous findings where we only looked at UK, going to our own country situations. It did reinforce the same findings. So if you're going to vaccinate, an early decision is important. Risk-based strategies shows potential, but it's possible that we can save on vaccine usage and achieve almost the same results by just vaccinating cattle. There's still questions over how well our models reflect the true species differences, so there's some skepticism about just accepting that at face value. And obviously resourcing is very important. Okay, so let's go on to further work that we've been doing is trying to predict when a large outbreak might be developing. That's another project that we've been involved with. And so if we're going to be vaccinating, we need to understand the best way to deploy vaccine and what sort of doses are going to be required and so on. And we want to do more work on risk-based strategies. Okay, and it's important, I mentioned economics here. It's important to balance your policies with what are the key economic drivers for our respective countries. Okay, so thank you very much. And there's a large number of agencies and governments that I need to acknowledge, so I'll just leave those up there.